set of rational. What are rational numbers?
From integers, including numbers that are adjustments to fractions.
Yes, but yes. Now, in less words, can you define it? But you're right. That is true. It's everything between two integers, right? But how would you define it? In simple terms. What part of mathematics do y'all hate the most? Yep. These deal with fractions. The first 5 letters of the word rational spells ratio, which is just that. These are the set of all numbers a over b such that a and b are integers and b cannot equal 0. Have we seen this kind of terminology or this type of notation earlier in this class? Yeah, it's called set notation. The way it's read, this Q symbol is equal to the set of all a over b such that a and b are integers and b is not equal to 0. We're still using the same stuff we learned in the first 3 chapters of this course. Because mathematics is all related to logic. A is called the what? It's called the numerator. It's also the dividend. The bottom number is called the or the divisor. It used to have another name, but we don't use it anymore. It used to be called the denumerator. In the history of math, our civilization was the last to introduce fractions. Historically, it started many, many, many years ago, and it wasn't a concept that merchants needed. For example, in Chinese, what this thing means is out of 4, take 3. That makes a little bit more sense than 3 divided by 4. I see what we aren't the top of the world when it comes to fractions. Fractions come from the Latin word fractus, which means broken or fractured. So that's what's happening. If we have a block and we break it up into 4 pieces, we've just now broken it up, and we take away some pieces, it's no longer an entire block. It's now just a chunk. And that's what it means. It's Out of 4 pieces, let's take 3. Out of 8 pieces, take 1. So we're gonna talk about all 4 operations here. Some of the procedures that we talk about, you may like, may not like, but pretty much what ends up is what you end up doing when you start teaching this to students is you'll teach it the way you feel comfortable with. Does everybody have the same procedures? No, probably not. So if I gave you something like, go ahead and simplify that for me. $38 divided by 160. Finish? Already? Where'd you get? Can't go any further? So yeah, yes. I mean, the first method you'll teach your kids is what method did you use? What would you call that method you just used? Well, so what you did is you know that 38 is 19 times 2. How about 160? That's 80 times 2. The 2's cancel. See, well, everything you do has to have a procedure. If you did that in your head, said, okay, they both have a 2 in common. Well, why do they have to do it? Well, the 2 have a 2 in common, so you can cancel them out. And so we talked about that earlier with prime factorization. We learned how to factorize each number. This is what we use it for. Is there another method? What were y'all working on? Did you? But again, the bottom line is this, is you have to know how to do this without a calculator. Because if you start teaching your kids in elementary school to use calculators, they're dead. They'll get to college, they'll fail out the first day of school. As you see, we don't depend too much on calculators here. So, and in the real world, how many times do you carry a calculator around with you every day, all day? You carry your cell phone, yeah, but eventually it gets pretty boring. Every time you do a question, let me get a pencil, but calculator out. Let me get a calculator out. Eventually, I'll say, I don't need you anymore. I do it myself. Have a good day. Bye. So, how do we check our division? Yep, because division and multiplication are what? Opposites. And a more mathematical term than opposites is their inverses. Rational. The first part of the word, ratio. How do you define a ratio?
Like the definition, the linguistic definition,
Or even in math symbols, math terms.
you can do like
Okay. What does that mean? Okay, so what does that mean? Remember, this means nothing to kids. Yes, you told me symbols, but nothing would means anything to me. How would you define this stuff? You told me that it's great, but what does it mean?
Like, I guess it's saying if I flip a coin 4 times, the amount of times I'm gonna get hits.
Yeah, that's an example. Yeah. So what you just said there was 1/4, which is 1 to 4. Ah, okay. So now we're looking at percentage. How would you define that in words? If a kid asks you in your classroom, what is a percentage? How do you define what is a ratio? You can't really tell them 1 to 4. Yes. Total amount of a number. There's how you define it. It's part, which I mean, everything y'all said was correct. But remember, you have to use the words that kids understand first. Because if a kid goes home and shows them this, they'll think you're teaching them how to gamble. That's the payoff at Mom, Dad, I need $10 for school tomorrow. We're gonna learn probabilities. It's part over total. Because percentage is just that, is the percent. It's the part over total of 100. This symbol is the word of. But this is the ratio. There are two types of parts over total we have. We can have, let's say, 2/3 or 3/2. What's the difference? No, both of them won't be whole numbers. If it was 2/4 or 4/2 to give you a whole number, both of these are gonna give you decimals.
Is it a big phone number?
You're close. You're getting close. You're getting very, very, very close. Actually, you said it, but you put too many words in it. Yes. These are called mixed numbers. Well, not really just yet, but they define mixed numbers. They're actually called improper fractions. Improper fractions lead to mixed numbers. 2/3 is called a proper fraction. Okay, with that, what do we notice about these two different sets of numbers? Proper fractions are what? Okay, the numerator is less than the denominator. Since that's right, what is the number always going to be? Yes. This is going to be less than 1. It's always going to be a decimal between 0 and 1. These are always going to be greater than 1. Let's look at this. We have two. Because this will be the first way you teach division, using this symbol. How many times does 2 go into 3? One time. So 1 times 2 is 2. Subtract. So this is my remainder. We talked about division earlier and talked about remainders and the bottom numbers and top numbers. How do we know that's going to be the remainder? Well, we know it's a remainder because this number does not fit in there. Since it can't go anywhere. So this is the whole number. So 3/2 has a whole number 1 and the remainder over the bottom. That is a mixed number because it has an integer and a fraction. It's mixed with that. So integer and fraction. Look for the examples that we had here. Ooh, on a number line. If we had a number line, I give you numbers. Plot the numbers. I give you some easy ones too. There. Because using manipulatives will be easy with the kids. Because if we give the first one, this one, how would they prove it? Just get one little block. If now, since you have positives and negatives, you have red blocks and blue blocks. You can define them as you want to. So where would this one go? That's the one. Just put a dot there. And that one. Now, how would you define 1/2? Yeah, which because 1/2 is between. So we put it exactly halfway between there. So that's 1/2. How do we define it 1/2? Because this thing says it's one piece out of 2. So here's 1, here's 2 pieces, and I only want that piece. So it stops here. And same thing there. Here's 1 piece, 2 pieces going to the left because it's negative, and I only want this first piece. How about 3/4?
But three lines between 0 and 1. And
Why 3 lines?
I'm using an analogy, 3/4 with a quarter. So to get $1, it's 4 quarters.
Are you thinking as an adult or as a child?
I don't know if you teach them how to come back. Do, like, skips in between, so do four skips or four jumps between the 0 and the 1.
Okay, but they have to be equal. See, that's gonna be a tough part for kids, because now how do you make them? Okay, so let's look at this. We have we have to have four spaces. So we have to, first off, we know the half. It's halfway between there. Then we have to define that half of a half. That's gonna be your first difficult part. A half of a half is a fourth. So this is 1/4, this is 2/4, this is 3/4, and that's 4/4. How many times does 4 go into 4? One time. How many times does 2 go into 4? 2 goes into 2 once, 2 goes into 4 twice, so this is 1/2. You have, see, this is what mathematics call inductive. You teach them something, and then you use that to teach the next thing. And that's why we start off with a half. That's the easiest one. Yeah, you're right. It's gonna be difficult. Now take this and you have to make it into 4 equal blocks. And you're right. It's always gonna be one less line than there are numbers of blocks. As you said, put 3 lines between there, because the 4th line is the end line. And if you really want to go technical, we'll say that's actually gonna be 5 lines, because you have a beginning and an end, and you have 3 lines in the middle. In 1/2, since there are 2 pieces, we're gonna have 3 lines, the beginning, the middle, and the end. So yeah, if you start doing that, it get pretty complex to the kids. And then we do the same thing here. So here's -1/2 and cut those in half. So 3/4 would be what? Start from 0 and go 3. 1, 2, 3. And left-wise. 1, 2, 3. And now you see why division and fractions are the least liked, because they require a lot more thinking than what you're doing. The next one. But it's not difficult. But once you understand what the concepts mean, it's just as simple as addition and subtraction. What does this one mean? 3/2. Yeah, you're thinking as an adult. What does the kid have to do first? Yeah, we have to get the halves. So between 0 and 1 is a half. Between 1 and 2, there's a half. Between 2 and 3, there's a half. So these are the endpoints, and the smaller ones are the halves. How many halves do we want? 3. 1, 2, 3. That's 3 halves. And then that's where you would say, hey, that's between 1 and 2. So it's bigger than 1. And how much bigger? It's 1/2 bigger than 1. Because remember, 1 plus 1/2 is 1 and 1/2, is 3/2. And that's where we get into now adding and subtracting of fractions. And same thing with the left side. We have to divide that in half. We have to divide the next one in half. And the next one in half. So teaching them, that's what the bottom number means. Between each number, we have a half. We want to go 3 spaces. 1, 2, 3. 6 divided by 3 and negative 6 divided by 3. So what's the concept you're going to teach the kids here? What do you look for first? It's the third. So we have to divide each one of these segments into 3 pieces. So there's 1, 2, 3, 1, 2, 3, 1, 2, 3. So how many of those do we want? We want 6 of them. 1, 2, 3, 4, 5, 6. That equals 2. You'll have to teach them graphing first, because they have to see it first to understand it. How would you prove that 6 divided by 3 is 2?
Making 2 circles. Make circles and then putting each dot till you get 6 and seeing how many you get inside. Then you get 3.
Would that teach them division? But I mean, you're right, though. Okay, we have 6 dots. 1, 2, 3, 4, 5, 6. We want to group them in groups of 3. That's where you get the circles, right? So how many circles do we have? 2. Right. That's exactly how you do it. Because you do stuff you've done already with it, and then pick up from there. So now we look at, well, let's look at prime factorization. What is 6 made up of? 2 times 3 divided by 3. Do they have anything on top and bottom that cancel out that are the same? What you're left with is just 2. That's further along, because then they'll say, well, so is 3 plus 3 over 3. That's 3 plus 3 is 6. But if I cancel 1, I get 4. You guys are going, I bet you guys are thinking you'll get 3. No, because when you cancel things, you're left with a 1. 3 plus 1 is 4. Yeah, you're thinking the way the kids are going to think, which is not bad, because understanding what they're thinking will make it much easier for you to teach them. So that's not right. How would you go about to show them that we can't do that?
One final about one. You get but in addition, because when you cancel out, you're left with a 1. You're never left with a 0.
Oh yeah, so it's saying that it's not going to be a right answer. But how can we go from here to show them the right answer? Think of what we've taught them already. What is multiplication? Or the first thing you define multiplication is as was turbo addition. 5 times 3 is 5 plus 5 plus 5, or 3 plus 3 plus 3 plus 3. So if I have the same number and I'm adding it together, that's multiplication. So here, I'm adding 2 numbers together. I have the number and I add it together twice. So now I can go, so you can only cancel in multiplication, because multiplication and division are opposites. Now we can get rid of those. We defined addition of same numbers, that's multiplication. So we define multiplication that way, and then that's the only thing we can cancel. Now we can say it equals 2, because we have 2 groups. It seems easy because we've done it all our lives. But try to put yourself back in those classrooms when you first learned math. See if your mom kept any of your old stuff when you were in elementary school. And see how that thinking pattern goes. All right, so that's pretty important there. Ooh. The fundamental law of fractions. It says the value of a fraction does not change if its numerator and denominator are multiplied by the same integer. It's a non-zero integer. But even if it is 0, it'll be the same answer. It'll be 0 on both sides. Believe it or not, we just showed it to you. What does 6/3 simplify into? Which is 2/1. So as it says, the value of a fraction does not change if its numerator and denominator are multiplied by the same non-zero integer. 2/1 is the same thing as 6/3. Why? If they are multiplied by the same non-zero integer. So 2/1, if we multiply the top by 3 and the bottom by 3, we get 6/3. In other words, I change the way it looks, I don't change the answer. That is what leads to simplifying fractions. I'm not changing the number itself, I'm changing the way it looks. (20/30). If we prime factorize those, what do we get? (20) is made up of? Well, yeah, because if it ends in a 0, we know it multiplies by 10. Because remember that sheet we talked about, division sheet? If it ends in the 0, it's divisible by 10. So we have 2 times 10. Same thing with this one. 3 times 10. Here are the numbers. Here is the same non-zero integer. I can, since they both are the same, I don't have to worry about them. So these two numbers, even though they look different, are the same numbers. With that, that leads us to what's called a proportion. What is a proportion? That's a proportion. If A over B is equal to C over D, what has to be true? That A times D is equal to B times C. That has to be true. And that's the reason we call this cross multiplication. How about that one? 3 over 5 equals x over 20. So what's the first thing you do? Yeah, so take 3 times 20. Since we're solving for x, leave it alone. So we have 3 times 20 over 5 equals x. Remember, whenever you're multiplying fractions, before you multiply them, you reduce. Because what you really did is this. You multiplied both sides by 20 over 1. Because that gets rid of this one. So when you put 20 over here, why is this simpler? Because now we can see how many times is 5 going to 20? Yeah, so 5 goes into 20 4 times. So 3 times 4 is 12. It's much easier than looking at 3 times 60 divided by 5. Because then you have to do division, you have to break it down even further. Now it's again, you see why it's much safer to before you move on, if the majority of your class understands the 4 basic operations: addition, subtraction, multiplication, division. Because once they understand that process, then all this other stuff is just changing one thing, icing on the cake, pretty much. So make sure they understand that before you go on any further. All right, let's talk about simplification. This is example 3. Simplify this as far as you can, unless it's already simplified. So there's A and here's B. So the first one, what the kids are going to have to do is break down 28. What's it made up of? Ends in an 8, so we know it's divisible by what? 2. 2 goes into 2 once, 2 goes into 8 4 times. 14. 2 times what is 14? Is 7. So 28 is 2 times 2 times 7 times A because B squared means B times B. $42 ends in an even number. 2 goes into 4 twice. 2 goes into 1 once. 21 is made up of 3 times 7. There are 2 A's and 2 B's. Now we do what? Just cancel. So the 2 is the same, so that's gone. The 7s are the same. 1 A is gone, and both B's. So on top, I have a 2. On the bottom, I have a 3A. Because we haven't discussed the concepts of exponentials yet. Eventually, when they get older, when they learn exponents, if you have the same base and they're divided, then you subtract the numbers. 2 minus 2 is 0. So they're all gone. There's 2 down here. There's 1 here. So on the bottom, there's more. So 2 minus 1 is 1 on the bottom. But that's when the like 4th, 5th grade. So there's our first answer. How about this one? What method are we going to teach them to use here? What does this top part mean? What does that mean? There are 2 A plus B's, right? How about the bottom? What can we use there? Remember this property? The distributive property? Well, this would equal AX plus AY. I also said that's distributivity. This way is called factoring. You can see what they have in common, take it out. Whatever's left goes inside the parentheses. What do these two have in common? If you take out the 3's, you have an A plus B. So now one of these cancels. And there's your answer. All right, the next two. C, x squared plus x over x plus 1. 3 plus x squared over 3x squared. And if you finish that one, 3 plus 3x squared over 3x squared. Can we do anything in this one? What? How? Okay, so right on the top, you're right. This means x times x. So on the top, they both have 1x in common. So I could take out 1x. If I take out 1x, all I have left is x plus 1. Because you see, the most common mistakes are gonna happen here is let's say that, okay, they both have an X in common. I take out the X, there's one X there, and there's nothing here, it's gone. How are you gonna tell them that there's a one there? You can add zero.
There's always a one. And there can't be vice versa.
Yeah, but that,
Is it also X, it's going to be all in one? Just whatever you get, whatever number you get for X, you're gonna put on top of the one.
no, yeah, you all, I see what you're saying, you said, it's whatever you factor out, you divide and see what you have left. And then, yes, there is a one, but how are kids gonna understand that there's a one in front of everything? Because they don't see a one there, there's nothing there, I said, but there's one there. Show me. That means now you have to start writing a one in front of everything. No, but it says, to make sure that each step you do, like we did over here earlier. How do we know this is right? That, so if we distribute, we get that. We can go from here back to here. If we multiply these, we have to be able to go back to this. But if we have nothing there, if we have a zero there, then there's nothing to multiply to. But yeah, what you guys said was correct. But you, remember, you have to try to get down to what the kids know already. Invisible ones, even adults have trouble with that. I can tell you the number of times students, when they factor out, will leave nothing there. So now these are the same. So the answer is X. How about the next one? Can the threes cancel? And then can the X squares cancel? No. Because if they canceled, okay, let's say if they canceled, what do we get? The threes cancel, you get a one there, right? And the X cancels, so you get one there. So you get 2 over 3x squared. How do we test if fractions are correct? Well, you multiply the bottom to that. If we remember, if we had x plus y over x equals, no, x plus x equals 2, x plus x is 2x over x equals 2. How do we prove that? Is multiply both sides by x. X plus x equals 2x. That's the rule of addition. But that doesn't work here. Because there's a plus there, that's one number. If it was a plus or minus, you can't split them up. That's where the distributive property comes in. If there's a plus or minus inside there, or between two numbers, you can't separate them. They have to stay together. This is as far as it goes. You can't do anything with it because nothing factors out of the top. And we can't cancel anything because you can only cancel if it's multiplied. You can only cancel if it's multiplied. Like the bottom one. On the top, they both have threes, so we can take out a 3. And then if this one's gone, what's in its place? A 1. And that 3 is gone, so we have x squared. Again, we have to be able to reverse the process to test it. Since these 3's are multiplied, I can cancel them. And there's my answer. Because this is addition, they have to stay together. And this is where you would reinforce the fact that 2 times 3 over 3 is 3. That's 6. I mean, is 2. Because they're multiplied, so I can cancel. I cannot cancel these because it would give me 3. And that's not the same as 5 over 3. So yeah. Yes, I'm not gonna lie. Division fractions will take the longest time to teach them, but they have to know the multiplication skills. And again, they have to know the addition, subtraction, multiplication, and they have to know remember the rules. Two fractions are equal if what? Two fractions are equal if we did that cross multiplication thing. Why is that important? So are these two equal? Remember, mathematics needs numbers, proofs. No, right, because if I do this cross multiplication, 2 times 4 is 8, 3 times 5 is 15, and they're not equal. So these are not equal. So this test is only good to see if they're equal. Can't do anything else. Because 15 is on this side, we know that this side is bigger than this side. This is called ordering rational numbers. Yeah, my question was, are they equal? No. If not, then which one's bigger? But once I cross multiply, then whatever number is bigger, that side is bigger. The example that we were going to cover here, Hector saw this graph. And the teacher asked, is this one's 1 out of 3 pieces? And this is 1 out of 2 pieces. Is 1/3, because it's the area, is it bigger than that 1/2 one? You see how the kids would think of this? Because yeah, that's a much bigger area than that. Is it true? ¿Por qué no? Ah, yes, because pizzas are the first thing the kids, pizzas and pies. Yeah, so let's look at if we had 2 pizzas the same size. If I had 1/3 of a pizza as opposed to half of a pizza, now we can see that 1/2 is bigger. So the size of the pictures, if you're going to use pictures, make sure they're the same size. But now, can we prove it another way?
Cross multiply.
Cross multiply. So we have 1 times 2 and 1 times 3. Is 2 bigger than 3? No. So that's not a true statement. Let's see what else we got. Oh, yes. You know the definition of greater than? A over B is greater than A over or C over B. If A is bigger than C. Now, if and only if. Is that always true? Yes, because as long as the bottom numbers are the same, as long as the bottom numbers are the same, then you compare the top. That's where we get the concept of what? Common denominator. So if we had 2 over 3, is it bigger than 1 over 5? Are the bottom numbers the same? How do we make them the same? Well, I take this number, multiply it top and bottom here. I take this number, multiply it top and bottom here. What is 5 over 5? Yeah, so anything times 1 is itself. So I'm not changing it. I'm just changing the way it looks. So 5 times 2 is 10. 5 times 3 is 15. 1 times 3 is 3. 5 times 3 is 15. Once you have the denominators the same, as this thing says, only look at the top. Is 10 bigger than 3? Yes. So actually, this is another way of saying what we just did. Oh, yes, there's another one. Dense. Consensus. Denseness. Yes. The density. Okay, what that means is if I have 2 numbers, A and B, then there's at least 1 number between them. In graduate school, we call this the Bolzano-Weierstrass theorem. So you mean any 2 numbers, I can find a number that's halfway between them. Well, for any numbers. I mean, any 2 numbers. I don't care how small they are. 0.0008, 0.0009. There's always a number between every 2 numbers because I can always divide it by 2. So that's what denseness is all about. the definition is, this is theorem 6-4. Given any two numbers, any rational numbers, A over B and C over D, there is another rational number between them. Given any two rational numbers, there is another number between those two. So between A over B and C over D. This is theorem 6-5. The way you find it is add the top numbers and add the bottom numbers. That will be a number, a rational number between the two other ones. So like between 1/2 and 3/4, 4/6 is between there. I'm sorry. There. So between 1/2 and 3/4, there's a number between there. Take the top numbers and add them. Take the bottom numbers and add them. It's always going to happen. Now we do the same thing between 4/6 and 3/4. We do the same thing there. Add the top numbers, add the bottom numbers. And of course, simplify. This one's going to be 2/3. That's between the two. So between 2/3 and 3/4 is 5/7. So we can always add those two numbers. It's always going to give us a number. All right, that's it for that section. And in the next section, next class, we'll complete the chapter. There are only 3 sections in chapter 6. We're going to do multiplication, division, addition, subtraction.